Hey guys, so we are starting the second portion of our, let's say, deep dive into ionic and covalent compounds. And we're going to start talking about how you name these compounds. Okay, so this is naming and writing ionic and covalent compounds, part 1. So the first thing we're going to do, just like we normally do, is we always start off with our periodic table. So your periodic table in terms of labeling at the top should look something like this. So you should have group 1 with an oxidation number of +1, and they have 1 valence electron. Group 2 has an oxidation number +2, and then you should have a notice that has 2 valence electrons. And then you have group 3 here, or should I say group 13, let me be clear, because we skip over all of the transition metals. They should have a valence of 3 with an oxidation number of +3. Carbon, we kind of avoid, right? But they have 4 valence electrons, but in terms of charge, we don't really look at it that way. And group here with nitrogen, this is going to be group 15. They have 5 valence electrons. Their oxidation number or charge is going to be -3. And then we have oxygen and friends with 6 as their valence electron, and then they have a charge of -2. And then last but not least, we have our halogens, which are all part of group 17, and they're going to have a valence of 7 and a charge of -1, or an oxidation number of -1. Once again, remember that the noble gases, they are happy. They have 8 valence electrons. They are completely stable. They don't want to gain or lose electrons, okay? So you should at least have those things on top of your periodic table. You might also have some numbers along the side of your periodic table when I was quote unquote walking your periodic table. You may have that information as well. Okay, let's get into naming. So we're going to get into naming all sorts of different compounds, and the way that you're going to know how to name is basically by the way that they look. So the first set of ionic compounds that we're going to name are called binary compounds. Bi means 2, okay? So they're going to be naming of ionic compounds that only have 2 elements. So when you're thinking about this, right, we should know that when you're making ionic compounds, it's going to be a metal and a non-metal combination, right? The metal is the one that is going to be transferring into electrons. The non-metal, hopefully, is the one that's going to be picking up the electrons. When we're writing the chemical formula, you always want to put the metal or the positive ion first, and then it'll be followed by the non-metal or the negative ion. And the big thing about binary compounds is that they always end in "ide", in IDE. Okay, so 3 things. It's always going to be a metal and non-metal combination. The metal is always going to be written first. The non-metal is always going to be written negative. Also known as the metal that's the positive ion will be written first, and the non-metal that's the negative ion will be written second. And then we were going to change the end of the name, that is a suffix, to "ide". Okay, so let's go through naming these ionic compounds. So let's give an example. So the example that we have is going to be NaCl. The compound is binary. It contains 2 elements. That would be sodium and chloride. Sodium is going to be the cation ion. Chlorine is going to be the anion. So sodium is going to be positive. Chlorine is going to be minus. The oxidation number, also known as charge of sodium, is +1. Remember, it is in group 1, so that's why it has that charge of +1. The oxidation number charge for chlorine is going to be -1. Okay, so now that we know that it's binary, now that we know which one is positive and which one is negative, now we need to figure out how to name. So you're going to name the metal ion first, and then you're going to name the non-metal or the anion, and then you're going to change the ending to "ide". So this would be sodium, right, which is the metal cation. Then it'll be chloride, okay? So instead of chlorine, it's chloride. So the complete name for NaCl is sodium chloride. Now, there are some exceptions to the rule. They're a little bit tricky, okay? And it's because we changed them because it really didn't make sense to leave them the way they were. So for example, nitrogen, we don't say nitronide, right? We say nitride. Phosphorus, we don't say phosphoruside, right? We say phosphide. Oxygen, we don't say oxygenide, we say oxide. And then the last one is going to be sulfur. We don't say sulfuride, we say sulfide. Okay, so those are the tricky ones that are, let's just say, exceptions to the rule. So nitrogen is nitride, phosphorus is phosphide, oxygen is oxide, and sulfur is sulfide. Okay, so now let's talk about how to write these ionic compounds. And we are going to use what we call the crisscross method. So we briefly referenced it when we were writing our Lewis dot structures, but now we're really going to go into detail. So it's used to write ionic formulas, and we're going to use the oxidation number of charge, okay? So as always, I like to give you steps. So here are the steps. Step 1, write the symbol for each element. Step 2, assign the oxidation number or charge for each element in the upper right-hand corner of the symbol. Step 3 is you're going to cross the number, not the positive or negative sign. Okay, so you're going to cross the number, not the actual charge. And then you're going to check the total charges. A molecule is neutral. That means the positive and negative charges are equal. Okay, so step 1, write the symbol for each element. Step 2, assign that oxidation number. Step 3, you're going to cross the number, not the sign. And then you're going to check to make sure that if you were to add up those numbers, that they would add up to 0. Okay, so let's go through an example, this crisscross method. So the first example is going to be magnesium chloride. It is binary, right? Made up of magnesium, which is Mg, and then chlorine, which is Cl. Now we have figured out what the symbols are. Now we're going to assign our oxidation number. So the oxidation number here, magnesium is going to be in group 2. That means it's going to have a charge of +2. Chlorine is going to be in group 17. It is our wonderful halogens. They all have a charge or an oxidation number of -1. Now what you're going to do is you're going to take the numbers and you are going to cross them. Okay, so there are 2 things we need to talk about, and we talked about it a little bit, right? So we talk about what a subscript is and what a superscript is, right? When we were doing our hyphen notation and all of the notation for our isotopes, right? And when we were also doing our beta decay problems, right? You had subscripts and you had superscripts. So here's the deal. What's really important here are going to be the subscripts. So when you cross those numbers, okay, it's going to look like this. Mg1, Cl2, right? The 2 that was next to the magnesium was brought down now as a subscript for the chlorine, and the 1 that was the part of the oxidation number for chlorine is now going to be the subscript for magnesium. So here's the deal. In chemistry, if you have a 1 as a subscript, we don't leave the 1. Okay, we just say that if it's written, that means you have 1. So I don't need to put a 1 to tell you that I have 1 if I already have 1. All right, so you're just going to leave it out. So the final equation for magnesium chloride is going to be MgCl2. All right, hopefully that makes sense. We will go through one more example for you, though. So the second example is going to be magnesium oxide. It is binary. We have 2 different elements. That would be magnesium and oxygen. Symbol for magnesium is Mg. Symbol for oxygen is O. Now we need to find their charges. So if you take a look, magnesium is going to be in group 2. That means its charge is +2. If you look at oxygen, they are group 16. Oxygen and all of oxygen's friends in group 16, they have a charge of -2. So now we're going to crisscross, take the numbers, bring them down as subscripts. All right. But here's the deal. It comes out as Mg2O2. But just like in math, you can simplify that, right? Find the common factor between them, which is 2, and take it out. Okay. So when you simplify it, it's going to end up being MgO. Okay. Hopefully that makes sense. Okay, let's try one more. So the third example that I have is going to be magnesium phosphide. Okay, it's one of the tricky ones in terms of naming. So we do have 2 elements, so it is binary. That's magnesium and phosphorus. Magnesium is going to be Mg. Phosphorus, if you take a look at the periodic table, is going to be P. Now we're going to look for oxidation numbers. For magnesium, the oxidation number is +2. For phosphorus, it is chilling in group 15, right? Right with nitrogen. All of nitrogen and its friends are -3. So now what you're going to do, you're going to cross the number, not the charge, and bring the numbers down as subscripts. So your final formula for magnesium phosphide is Mg3P2. All right, once you get the hang of it, it is pretty simple. You just have to get used to how it should be written. All right, so now, of course, you know, you're looking at me, you say, yo, it can't be all that easy. Well, there are some exceptions, and those are the transition metals. So I told you that the transition metals, they mess around with everything. Well, guess what? They continue to mess around with us. Everything in that D block just messes everything up. So here we go. Most transition metals are going to form cation ions or positive ions with different charges. So because of that, we need to find some way to differentiate between the same transition metal that has a different charge. So the way we do that is we use Roman numerals to indicate the charge. So an example of that in the D block would be iron. So there is an iron that is +2. So to make sure that we name it properly and make sure that we have the right amount of atoms in our formula, we would write it as iron, and Roman numeral will be in parentheses. And because it's +2, it's iron 2. Similarly, there is an iron that is +3, okay? So to tell the difference between iron that's +2 and the iron that's +3, we use a Roman numeral. So for iron +3, the Roman numeral name that we would use would be iron and then 3 in parentheses. When you are naming these compounds, you have to use the Roman numeral. All right, so let me give you an example of a compound that contains that particular transition metal. We have FeO, okay? So now you need to take a look and you need to decide what is the charge on this iron. Well, you know from what we've been talking about that oxygen is going to be -2. So if oxygen is -2, to balance out your compound, the iron has to be +2, right? +2 plus a -2 equals 0. That gives us a neutral atom. So now when you're naming it, now you know that iron has a charge of +2. That means the name is going to be iron 2 oxide. Okay, so now you might be asking me, so when am I going to use iron 3? Well, here you go. You have Fe2O3. In this instance, we still know that oxygen is -2. So if I wanted to figure out what the total charge was, right? -2 times 3 gives me a total charge of -6. So now I need to figure out how I can get +6 because my compound here is neutral. So I know that I have 2 iron atoms. That means that each iron atom has to be +3, right? If you have 2 irons that are +3, that means they're +6. So your iron total charge will be +6. Your oxygen total charge will be -6. Okay, so now we know that the iron that is in this compound has to have a charge of +3. So if we're going to name it, now we're going to name it as iron 3 oxide. All right, hopefully that makes sense. You guys are going to be doing a ton of worksheets where you're going to practice that. Iron is not the only exception, though. So there are some other exceptions to this concept. I know you guys were hoping that there were no more, but there are more. Okay, so some exceptions. Silver is always +1, and zinc is always +2. Because we know that they are always the same charge, no matter what compound you're writing them in, you do not have to use Roman numerals for these elements. Okay. Second one, tin and lead from group 14, they can have a charge of +2 or +4. So you always have to use a Roman numeral with tin and lead. All right, so the 2 exceptions, silver is always +1, zinc is always +2. You do not have to use Roman numerals with these elements. Tin and lead from group 14, they can be either +2 or +4. That means you always have to use a Roman numeral so that whoever's looking at the formula knows whether the tin or the lead has a +2 or a +4 charge. Okay. All right, so that is the end of part 1 of the notes. Hopefully you guys were able to follow along, and hopefully you guys will not have issues completing your worksheet. Okay? All right, y'all. I'll see you next time.